Sure. Okay, so on number 2, what's the first thing you need to do if you're going to use my method?
Well, number 1, we do have to use the log b that method.
Right, so we're just going to put anything there. We can put an R or a B, or you can put your name, right? Any base.
Yeah. But B is better. I like B.
Yeah, because it stands for base, right? Use any base.
Yeah, it's common sense, and I don't want to use. I don't want to come.
It really is. It is common sense to use base, and really it is a ratio, but because the inverse is an exponential function. But we're not going to get into that. We're just going to keep it to b because we've already covered that. So now what do we do? So we know that there's something else we're missing though. We need the same y, right? Need the same dependent variable.
So that means it's going to be the same thing again. It's going to be a log b. You're still going to use the the canceling inverse rule. So it's going to be log base 10 minus 4x.
Well, so let's go ahead. Let's take it step by step, right, and not do what Mr. Smasher was doing last time, right? I was kind of chasing my tail for a minute. Summer took its toll, right? So we know we have this, right? Step by step. This is why I was goofing up, not doing it step by step.
And equal because both of them equal y. So they said, oh, bro, this is similar equations 2.0. Now
But now we use the rule. B to the y is that, right? And then b to the y is that, right? So let's just do the left side and cover this side up. So what you can do is you can just, cover that up on the screen with your hand. On the right, you just apply the rule on the left while you have the other one covered up. We'll say b to the y is equal to 10 minus 4x. In fact, I should probably write that like this, b to the y is equal to 10 to the minus 4x. And then we cover that side up and we say b to the y, so it's already written there for that side. Now it's already written, see, which is nice, is now equal to 10 minus 3x, right? And since they're both equal to the same b to the y, because they were both originally, their logs originally, we now converted them to exponential form, they're still equal to the same thing, albeit b to the y. So then that means now that we can just say, okay, since they're equal to the same thing, I should say equal to the same thing, then that means that we can just set them equal to each other and solve for x, doesn't it?
Yes.
And this is relatively straightforward now at this point. You're going to have x is equal to 0.
Yeah.
Now, on these...
Yeah.
This is the end for you, my master. Ninja vanish!